at AUB. On behalf of the organizing committee, Professor Jihad Touma, Professor Sarah Najm, Dr. Ali Ahmed, and myself, I would like to welcome you all for the second webinar of the series lecture by physicists in policy, part of the Physics and Public Policy Initiative, an initiative that is undertaken in collaboration with the Lebanese CNRS, the AUB Isam Faris Institute for Public Policy and International Affairs, and the Department of Political Studies and Public Administration at AUB. The initiative was launched with the aim of exploring the productive interface between physics and policy for the benefit of our students, our colleagues, and the broader community. It aims at promoting the exchange between its parties, integrating public policy thinking in the teaching and the research of the department, contributing physics modeling and insight to public policy, and sustaining in-house physics research in fusion material science, non-equilibrium statistical mechanics, and computational physics. The initiative highlights the journeys of prominent physicists who engage in the complex landscape of public policy and contribute to the effort of solving societal problems. Some of you were with us in April, where we kicked off the series with Professor Zia Mian of Princeton University, who led a fascinating and stimulating discussion about the global effort for nuclear disarmament and the role of physics in moving forward towards a more peaceful world. This second seminar promises to be as exciting. It is presented by Dr. Adonai Herrera-Martínez, Associate Director of the European Bank for Reconstruction and Development, who will examine the challenge of accelerating climate change while achieving a developmental goal. The moderator for today's seminar is Dr. Ali Ahmed, a research fellow of energy policy at the Kennedy School of Government at Harvard University. At AUB, Ali is a senior fellow at the Isam Faris Institute, where he leads research on the political economy of the energy transition in the Middle East. Ali is also a senior consultant to the World Bank, advising on energy reform and planning in conflict and post-conflict contexts. Ali holds a first degree in physics from the Lebanese University here in Lebanon in Beirut, and a PhD in engineering from Cambridge University. Great to see you all here. Ali, the floor is yours.
Thank you very much, Malik, and thanks also to EUB's physics department and its partners, of course, for initiating this lecture series and this initiative. Of course, it's a great topic today, and we're all up for a real treat with having Adonai with us today. But before I introduce Adonai, I have prepared a few remarks that I would like to share with you on the topic of the lecture today, and also on the series in general. I think for anyone who engages with policymaking at any level, they will soon realize that making a good policy decision is an extremely difficult task, because there's often multiple policy options. Each option has its own, sometimes known and unknown costs and benefits. So beside creating the base for technological advancement, which is really essential for solving grand challenges, such as climate change, which is the topic of our lecture today, science can actually play another important role in reducing uncertainty in policymaking. So science can do a lot to inform policy design by making it based more on complete information and facts and evidence. But this does not come automatically, and it does not come easily. Scientists and policymakers often have a different style of communication, and they often operate at different wavelengths. Scientists often assume that it's enough for them to do the research and to provide evidence for their findings to be incorporated into policy. But in reality, there are sometimes other forces that are more powerful that govern the policy-making process, such as economics, societal norms, and plain politics. So it is in this context that the discussion about climate change, and climate change in particular, is perhaps one of the most pronounced venues where the complex relationship between science and policy is manifested. I think it is clear what science can offer to help address climate change. For example, since the beginning of climate issues, physics in particular has played a major role in in advancing climate science just by, for example, detecting temperature changes, estimating the amount of carbon present in the atmosphere, to understanding the mechanisms through which climate change takes place. And this is clearly the role of physics in climate change is a really fascinating topic. And for those who are interested in learning more about physics and also how physics historically played a part in understanding climate change and how it could play a part in resolving it or addressing it in the future, I highly recommend this latest book of Lawrence Krauss, which was released only a few months ago. The book title was, or is, The Physics of Climate Change. And if you are a YouTube addict like myself and you don't want to read the whole book, you can just check the recorded lecture on YouTube. It's a really fascinating topic, and I highly recommend everyone to check it out. However, there is another side of the coin. And I also believe climate change actually did impact science and did impact physics in particular. I think in some respect, climate change made scientists a little bit more comfortable in dealing and accepting uncertainty in the science they do. And I think on a more profound level, climate research has pushed a little bit within certain scientific communities the need to move beyond the search for a proof. Most of the time in science, looking for a proof is something that is very, very hard to get. Instead, we see that recently we have a shift towards looking for a consensus-based approaches that is mostly relating to empirical data. Also, I think that climate change has contributed to having more emphasis of ethical and moral issues and intergenerational equity, which are very relevant to the scientific debate these days. So based on this short introduction about physics, climate change, I think, and to discuss all these dynamics and the role of physicists outside the lab, and particularly those who are in the realm of public policy, we are really privileged to have Adonai Herrera-Martínez as our speaker today. And just a little note from my side before I introduce Adonai. I think when the organizing committee came together to start suggesting names, I think Adonai was the first name on my head, not only because of his incredible career at EBRD, but because we have also a personal connection that him and I, we both did our PhD at Cambridge. Actually, Adonai did his PhD before I did mine. And I remember in my early days of on the same, more or less the same topic, which I believe Adonai will talk about in a minute. But I remember our PhD advisor at the time coming to me with this thick and scary thesis of Adonai and putting it on my table. Essentially, it was maybe the first or the second reading in my PhD. And you can tell since then, I was really aware of Adonai as a person, but also I was aware of him as an incredibly smart scholar and thinker. And I think Adonai does not know this, but later in my career as well, after 4 years, I had to think about this shift from physics to public policy. And clearly, it's anyone in the graduate studies, it's a stressful time when you move and when you move from one side to the other, because there is a lot of risks and a lot of things to consider. But without having met with Adonai yet, I think just by following his career, I think he gave me encouragement that you can actually this option is open and it's doable. So with that, Adonai, I think we are really privileged to have you today, and we look forward to hearing your thoughts. Over to you.
Thank you very much, Ali. Well, thank you. First and foremost, thank you so much for the invitation and to be able to share my experience and share some thoughts on the connections between physics and public policy and share my experience. Ultimately, I think both Professor Tabal and yourself have mentioned several of the key drivers that triggered my career move, but I'll go into that later. What the key driver is actually to have an impact in the societal benefit, right? To have my work impact society for good, and that's probably what triggered my move from physics to public policy. I'd like to, before I move on to explaining and presenting a few slides, so you can relate to the work I've done. I'd like to introduce also my colleague, Katerina Stasiuk. Katerina and I both work together in managing the environmental funds that EBRD manages. Katerina happens to be also a physicist. And I think when we hired Katerina, it was not by chance that we hired her. When I saw she was a physicist, that added a lot of value in my, in my appraisal of her candidacy. Then, of course, the interviews were key, but the fact that she actually came from a discipline that focused on finding answers to problems and resolving problems and understanding why things happen the way they do was an important factor in our decision for all the selection committee. So Katerina, I don't know if you want to say a couple of words, but before I move on to my experience.
Thank you very much. I just want to say that it's a real honor and pleasure to be here with you, and thank you for inviting me. That's it. Thank you. And greetings from Ukraine.
Yeah, Katerina is Ukrainian. I would say one thing. I hope what I discuss when we prepare this discussion, this will be more of a talk, right? Where I will share my personal experience, my personal journey, if you wish, from physics to public policy, and I hope the audience will extract conclusions and will ask questions. I haven't prepared per se a speech. I've prepared myself to openly and candidly share what my main drivers for and you've said it well, Ali, a slightly scary and painful career change, and that's something that I had almost forgotten. And I must say, coming from an environment, it's good that you highlighted it. Coming from an environment where I had my team of colleagues at CERN. I used to work at CERN for 7 years. I was very comfortable in the theme of physics. I was pleased with the intellectual stimuli that I was getting from work. But then moving beyond that and saying, okay, I want to do something more for society. I want to see the direct impact of my work in the good of society. That step was a bit of a leap of faith. And at first, when I first moved to the UNDP and I moved to New York by myself, it actually was quite scary. It's interesting. It's interesting that you highlight it, because that's ultimately, if you truly believe that you're passionate about another field that you are where you would like to go, you need to prepare well, but you should take that step. That's what I would advise, right? One, and that would be first, probably my most important advice. If you're passionate about a theme, just make your best to do it, right? If you have been working on physics, but what you want to do is, climate physics or public policy on, on international development or gender issues, do it. Just understand what your path could be, but ultimately follow your heart, because you're going to spend decades doing that. So and physics prepares you well to address any kind of professional challenge. That's what I would say. If you want, I would start maybe with sharing a few slides of the work that I used to do at CERN, so you can actually relate to the courses and the activities in physics that you are involved in. Then I can share a few of the assignments that I did later in UNDP and then in EBRD, so you can understand how the skills from physics were actually quite useful in tackling even complex scientific problems, like issues that we had on supporting geothermal power in Turkey. So I'll just share my screen very quickly. I promise there's a few slides, but I promise to glide very quickly through them. And I honestly think that this would be useful for you to relate to the work that I've been doing until now. Let me see if I can. Yes, can you see the screen now? Yes, I assume you can see it.
Yes, thank you.
Yeah, okay, perfect. So moving on. First, a few slides on my physics at CERN. I was extremely lucky to be in a team with incredibly intelligent individuals. And I see this as my most intellectually stimulating part of my life. These are two photos of me 20 years ago, working with two incredible individuals, George Charpak and Carlo Rubbia, both Nobel Prizes in physics. In 1992, Charpak, and Rubbia in 1984. Charpak was given a Nobel Prize for his development of the multi-wire detector chamber that was then broadly used in all physics experiments. I'm very sure many of you have used a version of those particle detectors. And Carlo Rubbia was given the Nobel Prize for discovering the W and Z particles that are responsible for the weak interaction. So, of course, I was a very junior person when I was working with them. I was in awe by working with them, but they always, it was always a sheer luck to have to be working in a group with such impressive individuals. Then a lot of the work I did related to a lot of coding, and it's interesting because Ali, when I showed him the slides, he actually recognized one of the code. So I would say that 40% of my work, or 50% of my work at CERN and in Cambridge, especially at CERN, was coding. I focus on Monte Carlo coding, and I had to analyze, millions of data points in simulations, and then in the graph you can see the product of the cross section times the neutron flux. So basically, the reaction rate in one of the experiments we were simulating for different neutron energies, right? So that took a big portion of my work, Monte Carlo simulations, as well as development of experiments, and we were working very much on a neutron time of flight experiment to actually measure cross sections that then we would, because they actually, the pool of cross sections for transuranics and lanthanides was very poor, and fission fragments was quite poor. So we needed to, in order to properly simulate, we needed to complement nuclear data for different neutron energies. So what we did is we measured with a very accurate and very innovative experiment, neutron time of flight of 200 meters long. We did measure a lot of cross sections. So and the use of cross sections ended up, being applied to our Monte Carlo simulations, and especially given the fact that my research was focused on elimination of nuclear waste, of transmutation of nuclear waste. So basically, we were designing pilot reactors, and this is an example of the energy density of one of the reactors we were planning to prepare, as well as modeling reactors, like industrial-sized reactors, for the transmutation, for the elimination of nuclear waste. And then, additionally, we had a few very interesting alternative assignments, and I placed this one because this is probably the most exciting assignment I ever did. It didn't yield in anything tangible because we were just checking if the concept made sense. But I worked directly with Carlo Rubbia on this. I mean, he actually took over my management and made me actually work on this night and day for a few weeks. It was a project of humanitarian demining. He came up with the idea, he obviously is a genius. He came up with the idea of using a neutron source in order to try to detect landmines, because landmines are typically, they're explosive in landmines is typically a nitrogen-based explosive, and nitrogen 14 captures neutrons with a relatively high cross section, and that neutron capture emits a very characteristic, I think it was 14 MeV gamma, and that's a very unique gamma. And so our modeling planned to use a neutron source of a certain type, then irradiate the mine, and then detect the gamma emitted, the 14 MeV gamma emitted by neutron, by the neutron capture, by the nitrogen, using a certain type of gamma detector. And we were testing different gamma detectors. Ultimately, we dropped the idea. It was a fascinating exercise also because of the impact this could have, of course, the humanitarian impact this could have. But then we realized that the neutron sources that we had to use were excessive for having an accurate measurement on detection of the landmines. We would have needed a very high neutron source that would have been a very dangerous kind of source to handle. But this is yet another example of the kind of work we were doing at CERN. Very brilliant ideas that we tested and we wrote papers about and tried to push forward. Then, as I said, I moved to, after 7 years working at CERN and my PhD, and I remain at CERN as a postdoc. I moved to I realized that I really wanted to turn my career into international development in order to have a direct impact in the welfare of society, especially of the poor. So I decided to then apply for UN jobs and apply for an MBA at the same time. I got into an MBA, into an MBA school, by the way, where I studied with many Lebanese. By the way, I developed a lot of friendship in your country. But in the meantime, before I moved into the business school, I was hired by the UNDP to do a bit of econometrics and work with numbers. And that's a skill that is extremely valuable in international development. The ability to actually quickly understand, what to do with a lot of data and how to pick up, formulas that for an economist or a financier are complex, and for us, they're pretty simple, right? When you're talking about logarithms, that's our bread and butter. A logarithmic formula is our bread and butter. A quadratic formula, like the one you see at the bottom of this, is also easy to compute, easy to simulate, easy to input in Excel. Whereas for my colleagues at the UNDP, it was a bit more challenging, right? And this is an example of an assignment I did. Then we published a report based on this, on the evolution of costs and different type of costs for sustainable energy project in India and in West Africa. This is specifically is in West Africa for the multifunctional platform program, right? So the idea was gathering data sets and costs from the different small entities implementing this program in West Africa, in Mali, in Burkina Faso, and in Mali and Senegal. And then we extracted conclusions. We analyzed data and we extracted conclusions and planned how this technology could be scaled up into to provide sustainable energy for the poor. So and all these formulas, I did the research on what economies of scale meant, what were the formulas modeling economies of scale, and it was a quite an interesting step into international development, and I felt quite rewarded. And another assignment I did, and that was quite interesting. This is in French. I know in Lebanon you are trilingual, so it's actually great. This is also work I did for the UNDP. Coding, as I said before, coding was my bread and butter, and that's, I'm sure it's yours as well. And what I did is I coded a Visual Basic Excel tool in order to help policymakers in West Africa plan development scenarios, input entries and boundaries for development scenario for different sectors, and then see what were the yearly investments and the outcomes that those investments would yield based on analytical data from other programs. For example, the impact in indoor air pollution that improved cook stoves could have in the population of West Africa, for example. So it was an interesting exercise, and again, something that traditionally international development was not able to develop. I mean, the few people, even Katerina can confirm this, in the EBRD, almost nobody does Visual Basic coding, and we need very strong. I mean, right now I would love to do this kind of work. Right now, I just don't have the time, but I would love to be able to work with junior people that actually can help us automatize our processes, because automatization and now artificial intelligence is key to improving processes. And then moving on to the work that I've done for the EBRD. For the EBRD, my focus has been mostly on climate. And this is an analytical work we did with McKinsey on the effective allocation of resources. These are the McKinsey cost-effective curves for different climate technologies. The negative are net benefits, and the positive, the positive lines are actually the cost of carbon that those technologies would require in order to be implemented. These are called the marginal abatement cost curves and are very popular in the climate arena, right? Then and with this, I think I'm almost about to finish. I have 2 slides more. Another area, another topic that I felt passion for is geothermal power. I was based in Turkey for 7 years, covering sustainable energy, and geothermal power was probably the most interesting source of renewable energy, because it's a perfect combination of geology, engineering, and public policy as well, because it requires some sort of support. And this is the work we did on trying to model some non-condensable gas emissions of geothermal power plants. Again, this is something that nobody in the bank was willing or interested in tackling, but we ended up gathering data and doing regressions and modeling the evolution of CO2 emissions from geothermal power from the melted rock that the reservoirs have. So again, the fact that I was curious and I was willing to, to put some effort and some thought on developing a model was key. Otherwise, ultimately, we wouldn't have continued investing in geothermal power. And right now, we are involved in, and this is not so much physics, but it involves a lot of modeling. Right now, my focus and what I'm excited about is how we can help policymakers value and valorize natural capital. So basically, how we can valorize natural assets like national parks, like coral reefs, like forests, because typically when in policy making, when you don't value something, when there's no value attributed to something, the default value seems to be 0. But policymakers, they need to understand the value of natural assets to make ultimately investment decisions. Think about the construction of an airport next to a coastline where there's a mangrove. One could think that a mangrove has little value, right? You don't plant anything there, you don't use it for as a beach. But on the other hand, very often mangroves actually protect infrastructure or inland infrastructure against extreme weather events. They also serve to promote biodiversity in the neighboring ecosystems as well. If you don't look at those ecosystem services that those mangroves provide, a policymaker, a non-informed policymaker, might end up attributing a default value of 0, and that's a massive loss for society as a whole. So our intention is to actually develop a methodology that might not precisely and accurately calculate the value of natural assets everywhere in the world, but at least will take us a step further in understanding what is the value of the ecosystem services different ecosystems provide to society. And this is fascinating, because this is at the forefront, I would say, and I can stop the presentation here now. I could say that climate change is already mainstream, right? Everyone is investing in renewables, and that's great. The fact that now there's a green investment tsunami happening. People investing in solar plants, in renewable, that's great. And I'm not sure we will get to the 1.5 target of temperatures increases, but we are in the process of mitigating the risk of a much larger temperature increase. So that's great. Yet now the frontier in the sustainability investments is the protection and the valorization of nature. And that's that's where my curiosity and my willingness to have an impact in society combine, and the reason why I'm very excited about getting involved into these kind of projects. I think that this is it. Ali, I'm not sure if you want to start with the questions, or Katerina. Maybe Katerina should explain a bit her experience.
Yes, thank you so much, Adonai. Indeed, actually, this was the plan, is to have also Katerina's reflection, also not only on the shift from physics to international development, but also on the topics that she works on. And I understand there is some sort of overlap between her work and your work as well. Katerina?
Thank you very much, Ali, Adonai. Let me maybe start that I have a master's degree in physics from Kyiv National University, which is top 1 in Ukraine. And after that, I still believe in lifelong learning. So I had a couple of other educational programs involving project management and policy and governance program. I work with Adonai, managing Ukrainian window of one of the environmental funds he is leading, and this involves a broad knowledge on different areas, starting from district heating, energy efficiency, waste management, and this is such a various range of real actual infrastructure projects to be implemented, which are contributing to reduction of CO2 emissions in general, and this is our purpose. So this is the link to currently environmental policies. What bring me to this work, and how my migration from physics to public policy started, mainly through implementation of the projects, different ones managed by EBRD. Originally, I've been at the side of the contractors first, and then I joined a program which was called Ukraine Reform Support Architecture as a project manager. And I really like this joke that only physicists can manage the house, So whenever is going on around you, if you're a physicist on your background, you will deal with it. And I completely share the statement which Adonai expressed, that physics prepares you quite well to any challenges, because then your mind is set the way that you are solving this task, and you see options which can be hidden for someone who is not who doesn't have this experience in physics. Also, just to maybe echo Adonai on coding experience, when I was doing a public policy and governance program, that was really fun, because we had a number of participants, some from civil sector who had very extensive experience being public servants. Some were just trying to switch from one area of work to another. And there was a module where we had to manage big databases of different social data, like gender and like inclusiveness, like regions, when designing policy. And we had to code this all in this R coding program, which is simple for those who are dealing with coding on everyday basis. But this may be still such a big challenge for those who need to develop a public policy for the country, and they have no idea how the setup is dealt with the coding. And this really helps to design possible outcomes of the policy being introduced. And coding and modeling and physics approaches are crucial and necessary when implementing these policies, because sometimes what is perfectly designed on a paper can deliver some opposite results because you don't include all the affecting indicators. And that's why seeing something which is hidden from usual people without this technical mindset is an advantage. And I would also like to echo Adonai that if you wanna try yourself in any other area, just don't be scared. You just go for it, and you'll see that you can make everything if you are passionate for this. Thank you.
Thank you very much, Katerina. Thank you. And Adonai have given us a lot of things to think about. And also, while the audience is still absorbing your wisdom and your words, to think about questions. And I do encourage the audience to ask questions. and be more interactive, be it on by raising their hands or on in the chat room. I have seen that some have already started to ask questions on the chat room. But yeah, I think it's important to, I think I see here two venues of questions or two streams of questions that one can ask. I mean, the first one, Katrina and Adonai, you've worked on such important and relevant topics that, you know, we would like to know more about. And like, we would like to know about the role of technology in climate change. We would like to know about how can we manage climate change, not only in developed country, which seems, you know, straightforward, to more difficult countries such as the region, where you have a complex political economy and you have oil and gas industries, etc. But also I see another venue or another stream of questions that are related to your impressive career paths. And I think you have already shared a little bit of your career, and I think it's a mine of information that all of us can actually can benefit from. So myself, I have plenty of questions. I will ask them when the right time comes. But since I have seen some hands already being raised, so let me go to the audience. I'll start with Ali Badruddin.
Okay, good afternoon, everyone. Thank you for this amazing talk. It was truly insightful. Well, actually, my question goes into the career path venue. Well, I've seen that you have talked a lot about coding and computations, and I'm really interested in those paths. And I've seen that you already mentioned the automation of data collection and analysis, and it's something I've been working on recently a lot. So my question is, what can I do to help and to contribute to your work?
What can you do to...
Just to clarify, I'm sorry, Adonai, I think, Ali, just to clarify your question, what can you do in terms of career steps or education?
Well, it can be both. It can be starting with an internship as someone who recently got a bachelor, and eventually reaching to a long-term career.
Adonai?
Yeah, these are always complex questions to answer because they depend so much on the individual. The first thing let me share my experience. You can extract conclusions out of that. The first thing I did was when I entered into a mid-career crisis, to call it somehow, right? After I finished my PhD, and I started wondering what I wanted to do for the rest of my life, right? So basically, I tried to project myself in 20 years and say, where would I want to find myself? So then I backwards engineered the steps I had to take to get to that position. For me, it was very enlightening when I was doing some research on different positions in industry, in consulting, strategic consulting companies, in international development. I always had an interest for international development. But then within that world, you need to research exactly what you want to do. For me, seeing a position open in the Inter-American Development Bank, I still have it printed as a PDF, describing a job. When I saw that job, it was a chief sustainability investment officer. When I saw that job, I said, that's the kind of work, the kind of job I want to do in 10 years. So I basically built my career moves based on that focal point. That worked for me because right now, to a certain extent, I have the job that I wanted to have 10 years ago or 15 years ago. But my advice would be project yourself in the future, see where you want to get, and try to understand what you would like to do, and then see what are the interim steps you need to take to get there. And as another area of another answer to that question is indeed programming, artificial intelligence. Those are skills that are key for any kind of job you might do, because that automatizes and improves any system you do. From law, I mean, I was reading an article some months ago that was challenging, was actually suggesting that lawyers in the future will not have so much of a work because artificial intelligence will replace the kind of the legal practice, analyzing cases and evidence to the work we do, right? So whatever you do on automatization, big data, and artificial intelligence will be very useful in your career. That's my personal impression.
Katrina?
Well, maybe just to say that I also been doing some kind of research for future professions, and I've seen that generalists will be a profession of future, meaning that someone who can deal with different areas and still be good not to the knowing all the details of the different aspects of the profession, but being good enough to provide advice and to manage the processes. And I just think that physicists are perfectly fitting for this type of work, because you are already dealing with such a number of different streams and data and numbers that managing something, generalizing some general knowledge on other areas will be very maybe interesting and challenging, but at the same time something which you could easily do.
Great. I think the only thing also I would add from my own experience, and I fully relate actually to what Adonai said about this reverse engineering your future. And I think it's such a powerful concept. It sometimes also life is random, and life sometimes can throw at us different things. What is important also to sometimes be resilient and understand that this trip should not be linear. This trip can, for example, you can take a pause, you can take a side trip to the side, or sometimes you can, things can happen. And for example, now the COVID-19 pandemic is a great example where I am sure a lot of people have been unfortunate with missing out on important opportunities just because the pandemic happened and so many opportunities have disappeared. My advice here is, and also advice to myself, I say this to myself sometimes, is just don't lose sight of the bigger picture. And even if sometimes there is some short-term challenges, try to keep this long-term vision there. I think Ali, if I'm not mistaken, just to say, Ali is a physics student at AUB, and also I would like now to ask those who are asking questions to introduce themselves, so the speakers also can get a sense of who is asking the question and what stage of life and career they are at. Okay, so next I have Philippe Schiet. Philip, I think.
Hello. I was trying to make Zoom works. My name is Philippe Schiet. I am a consultant. Originally, I'm in applied physics, which means I am an engineer from start. And I was a student of Ali's previously in 2007, because I made energy study in AUB. I graduated in energy study, in a master in energy studies at AUB. My question a little bit is technical and not technical. It's related to what do you think of climate change and crisis country, as you were talking about modeling, and because when you have a crisis, generally all the data series are lost and cannot predicted. So the problem with policymaker is that what policy you will take with countries in crisis, especially for an important topic like climate change. And for example, Lebanon, Syria, Iraq, and now Palestine are countries in crisis, and the implementation of a climate change policy will be very difficult. I'm sorry for this little bit philosophical questions.
Thank you so much, Philip, and it's lovely to see you. I hope you are well. I think, Katrina, since you are based in Ukraine, and perhaps we can make a safe assumption that Ukraine is a country in crisis, can you perhaps take the first stab at this question?
Thank you. Just maybe to say that I'm currently also a student, and I'm doing some sustainable leadership program at the Swedish Institute. And we had a wonderful lecture by one of the representatives of this institute, Caroline Westblom, and she said that it's not the countries in crisis are being the biggest danger for the climate. It's those which are the most developed countries with the most advanced technologies. And of course, every country has to consider how to mitigate CO2 emissions, how to contribute to lowering the temperatures, how to protect their environment. But at the same time, my opinion is that everyone is responsible for its own input to the environment. But at the same time, the bigger the country is, the more advanced the economy and industry, the more harm the country is doing. So countries in crisis, maybe, of course, they shall consider this, but if they have some more emergent needs to address at the moment, maybe they just need to foresee for the future policies some actions. While those which are stable countries with advanced economies, with industries which are regularly polluting the environment, those countries are in charge and they need to take immediate actions. Otherwise, by 2030, if the temperature would go up and we may lose quite a number of biodiversity types, and this would affect our lives hugely. So I don't know whether I'm answering your question, but for countries in crisis, this shall be considered, but shall not be the first thing to address at the moment. And speaking of Ukraine, I would say that even though we are now in a special condition of, I'm not calling this war, but that some special relations with Russia and with not that advanced economy, Ukraine is struggling and preparing its input for the EU Green Deal to provide actions and a plan which will be implemented over the years. And here we are, the FFP fund, who helps the country to actually implement renovations of the buildings, to renovate district heating systems, which are the most CO2 emitting systems in the country, and in such a way mitigate the impact on climate. So it doesn't mean that if your country is in some type of crisis, even this is something very close to war, you are not taking care of the environment. You may still distribute your resources properly and define what is the most crucial at this point, and you can still try to handle all the aspects. Thank you.
Great. Adonai, any thoughts to add?
Yeah, it's a complex question. Let me first say that I'm also originally an engineer. I became a physicist at CERN, Philippe. So yes, I did kind of evolve as well, thanks to the work I was doing. So we have that in common. To your question about the lack of data and how that can affect our policy making. Look, obviously all my responses are my personal opinion. I see this as an all-out, climate change is the climate crisis is an all-out war to mitigate and adapt to it, right? If you look at the national determined contributions prepared by all parties of the Paris Agreement, do not add up to the efforts that the world, that globally we need to put forward to keep temperatures below 1.5 degrees, okay? So even the consolidated promises that countries have made are not enough. So we collectively need to make the most to mitigate against climate change. And then I will speak about climate resilience and adaptation later. But also the important point is that many of the actions that we are considering and that we are acting upon make business sense. And let me give you the example of the decarbonization of the power sector. Nowadays, renewables are by far the best source, the cheapest source of energy compared to fossil fuels. And we're talking about levelized cost of energies and the bids that investors are giving in countries like not just Saudi Arabia, where they have a lot of irradiation for solar, but we're talking about Romania, we're talking about Bulgaria, about Turkey, about Spain, my home country. So renewables, we need to make a paradigm shift. Renewables 20 years ago, 15 years ago, they were called alternative energy. Nowadays, they are the mainstream energy. precisely because they are the cheapest source of energy right now. Okay, the kilowatt hour produced from solar or from wind is the cheapest compared to gas, compared to coal, and that's not taking even the environmental externalities in terms of emissions and pollution that those sources of energy incur. Okay, if we're taking the societal costs that are the environmental externalities, that's even much more expensive. So it's a no-brainer. Okay, when we're talking about other type of investments and measures like the electrification of the transport sector, which is the key, that is true. Electric cars are more expensive right now, and the infrastructure needs to be put in place, right? But so did the railway infrastructure, so did roads 1 century ago. That doesn't mean that we still need to make an effort to put forward the required infrastructure to decarbonize our economies. Why? Because that's the right thing to do, both collectively, but also for our countries. And on the specific lack of data that countries in crisis might have, like Syria, like Eastern Ukraine, maybe. Well, this is where the role of methodologies, proxies, and international players come into play. I think personally, I work for a multilateral development bank. I believe that's the added value of the multilateral agencies, right? To be able to connect the dots between countries and understand what works in one geography, why, and how that can be transposed to a country like Syria or a country in crisis. Obviously, in order to make anything systemic at countrywide level, you need rule of law and political stability. That's key. And that's something that no entity can supplant beyond the government of a country itself, right? The best we can do is if we interact with with a functioning government, what we can do as external institution is engage in policy dialogue. I spent 7 years in Turkey, and Turkey, even though it's an emerging country, it has a very, very strong bureaucracy, and regardless of political assessments and opinions on politics, it has a stable political system. So it was quite beneficial to be able to interact with our counterparts at the Ministry of Environment, at the Ministry of Energy, and put forward strategies for, I wouldn't say decarbonization, because Turkey is a very special country in the Paris Agreement, hasn't ratified the Paris Agreement, but at least to minimize the emission impact in the power sector. And the truth is that the grid emission factor of Turkey has declined enormously over the years, in the last 10 years. So I think that that might address your question. We need data, we can use proxies, but what we really need is a functioning government that applies a rule of law and favors long-term strategies and also investments.
Indeed, I think just a follow-up on this lack of data.
You're the expert, Ali. You're the policy expert.
I think this is really, as you said, like both of you, this is a real challenge in many development contexts. One of the really exciting work that I work on with Professor Sarah Najm, who is with us today. Sarah is also, as you heard earlier, she's professor at the physics department. Starting with looking at Lebanon's energy sector, and clearly, as you know, like in order to understand fully how energy sector performs and what are the opportunities for distributed energy and everything else, you have to have a level of good data, right? Which unfortunately we don't have. So I think one of the exciting things that we've been working on is, mainly Sarah, I'm just on a free drive, essentially is, developing machine learning techniques that whenever there is data, you can apply machine learning processes and methods. And then sometimes, and I say sometimes, not always, sometimes these protocols can be extrapolated to contexts where you don't have enough data. Sarah, maybe feel free to jump in now. I hope I'm not killing the idea.
Well, thank you, Ali. It's really, I was also going to follow up on Philippe's question with a question that I've raised my hand, because in our context, again, there's the lack of data. We were lucky to have a couple useful data sets, but generally it's the other way around. So in the context of lack of data, and Adonai and both of you and Katrina, you've mentioned this machine learning and big data skills, but I think, and being computational physicist in the room, I would really still encourage students because to keep on the modeling approaches, because it's not always this bottom up, it's always the top down approach, that you start with the model and then you go down, rather than just starting to building a model from the data. And I think this, our students, I hope they're starting to appreciate, because the lack of data is the norm in our part of the region. It's not the other way around. So building models top down rather than relying on data is an important skill that I think physics students have appreciated, and I hope that this idea of complexity and like joining statistical physics with computational is an added skill that they I think Adonai and both Katerina, you should probably have seen this in the context of development.
I think you couldn't be more right. I couldn't agree more with you, Sarah. I think you're absolutely right. In NDB work, again, the big difference between physics and the work we do, one of the big differences, obviously, whenever you deal with economics, whenever you deal especially with finance, international development, you don't want, the goal is not to understand the minimum detail of a problem. It's to actually find workable solutions, if you want, in a very narrow time frame. So I think the idiom of the perfect is the enemy of the good is quite applicable here. If you miss data, indeed you need to develop a top-down model that might be acceptable, reflective of the reality, even though it might not work 100% of the time, because in social sciences and economic sciences, nothing works 100% of the time, right? There's so many variables, so many parameters that nothing can be accurately modeled, right? There's too much chaos in the system. And a good example of this is the example I gave on natural capital, right? You can imagine, how can we try to put an economic value to ecosystems, to biodiversity, to the number of species. So the breadth of species and the individuals, we cannot measure the number of individuals. We can only measure proxies. What is the value of ecosystem services? What's the value of bees pollinizing our, apple orchards? There's work on that. There's work on that economists have carried out on that, and it's obviously so. The important thing is attempting to model this kind of thing, and then if you want, incrementally improve our models to be able to start resolving a very complex problem. I think that's the way we will be approaching this issue. And by no means I'm an expert on biodiversity accounting. I mean, I'm learning enough to be dangerous, as my boss would put it. But I would link that attitude to physics as well, to the willingness to learn and to understand things and to do and to resolve problems, right? And there's a very clear overlap of these problems and technology, because some of the solutions to this lack of data and difficulties in understanding how many parameters interact are resolved by technology. Think about deforestation, again, and on biodiversity, about the Amazonia, about the use of imaging, satellite imaging, almost instantaneous satellite imaging, where you can actually identify where forests are being lost, what is the density of forest, how much is being lost, what could be the implications to the species living there, right? And then extract conclusions out of that. Same thing with coral reefs. Same thing with a fund that Katerina and I work together. The eutrophication, that is the generation of plants that kill ecosystems in the Baltic Sea. We've seen satellite images and the impact of our work in the Baltic Sea, in the reversal of the eutrophication. So again, just to reiterate what Professor Najim mentioned, yes, sometimes we shouldn't try to have full perfect visibility of data before modeling. So that's we need to just try to model and see how we can refine the model to predict the future with a few data points.
Fantastic. Actually, Adonai, in your answer, you have answered a question in the chat. I think Muhammad Dairaki, he was skeptical about modeling natural capital, and I think you have answered him. But again, if not, Muhammad, feel free to get back to us and let us know if Adonai answered you or not. So far on my list, I have 3 people, or now 2 people. I have Ru'a and Reem Salame and Sarah Hamad, but Sarah disappeared. And also, of course, Malik Tabbal. So let me start with Ru'a.
Hello. I just wanted to ask, is like physics still an important major for future? But like most people say that, you know, computer science is the future in technology. And I know physics is just important, but how can I convince someone that physics is still important for the future? I don't know if my question is a little bit far from the topic though.
No, on the contrary, it's actually in the heart of the topic. Who would like to take first?
I've spoken a lot, Katerina. I think you should take it.
Thank you very much for this question. You know, it really sounds to me like something personal, and I can tell you why from my personal experience. My daughter just finished the school, and she is now going through all this entering the university exams. And we've been through this painful process of thinking what direction she may be or will be willing or wants to go through. And I wanna give her a freedom of choice. But what surprises me that she still looks at some technical specializations. And that is not something like cyber technology, which is modern and now like very sound, but she's looking at something more technical. And she even asked me whether she shall try physics because she can observe my example. So just to tell you that I believe that physics is one of the main disciplines now and forever. And if you are a physicist by background, you can then redirect, restructure, redesign your career. But the knowledge you receive is crucial. And then I think that like just a few years ago, I'm speaking about Ukraine now because I'm not speaking about, I have experience of my country, right? At the moment when I entered the university, and that was a millennium leap year, like many years ago, right? There were not that many women on the faculty entering the specialization, entering physics. And the tendency is now, because it was like we had 80 students per course and something like 10 to 12% were females. And before our discussion today, I checked with a few of my colleagues and friends who are still working in the science in the university, what is the percentage? And I was surprised to see that now it's like females are around 40% of the students, which means that everyone understands the importance and opportunities of physics and the ways forward which it does open for development in professional life. That's why maybe there is no such a need to persuade someone, because the environment changed the way that new generation understands the value of education, of science, and especially of physics. Well, that's my personal intake.
Thank you, Katerina.
I agree with Katerina. I think physics is extremely important. I think what I would say, I would reiterate what I said before. You need to do whatever you're passionate about. Passion is the key driver. So if that's physics, you should go for physics. If you are uncertain, if you're not sure, physics is a good tool to actually acquire the skills that would help you find your way in the future. One thing that Ali mentioned before, and I think she spoke about perseverance before, about once you have an objective, a career objective, what to do, you should persevere. And it's a very interesting point, because I think the single most reading about business drivers and success drivers, I think what is recognized as the single most relevant trait to have for professional success is actually grit, which is a mix of perseverance and resilience in the face of adversity. So once you know what you want to do in the future, persevere, and you will surely find difficult times, but you should keep persevering as long as that is your objective. Grit is probably the most important. And the second most important trait is probably developing soft skills, because you will have to work with people everywhere, from physics to business to politics. Soft skills are essential. And that's also a path that I've gone through, because from changing from working in a lab to working in a multilateral development, engaging with 2,000 employees and then however 1,000 stakeholders, is a challenge, right? So do what you really want to do in the future, and persevere and develop your soft skills.
Great. So now I have Reem, Sarah, and Carol. I hope I'm not saying the wrong order. Why don't we start with Reem?
Hello, everyone, and thank you for such an interesting discussion. I'm Reem Salemi, and I'm a PhD student at the University of British Columbia, and I was also Ali's student. I'm not a physicist, but I'm interested about the discussion. So basically, Professor Adonai, you have talked about a project that you're working on about encouraging policymakers to value natural assets. So when you develop a methodology to value ecosystem services, do you intend to give a dollar value for assets at the end of the day? And do you think that there are other metrics that could be used and could be presented to policymakers to better, to help them in issuing their policies?
That's such a good question, actually, such a current question. First of all, I'm not a professor, so I wish I was a professor, but I haven't got to the level of Professor Najim and Ali yet. Hopefully in the future one day. But you're spot on the question. The idea is to actually put a certain dollar value to the services nature provides, not to the asset itself, not to nature itself, because some of us, and I include myself in that, my mother is a conservationist, a biology professor, so this is part of what I grew up with, right? I believe that nature has an infinite value, is invaluable. But the services it provides can be valued because they have an economic value and a societal value. So the idea is not to say, okay, can I trade my forest for this amount of millions of dollars? Because no, the idea is to say, no, when you take the decision of building a football stadium in that virgin forest, think that society is going to lose, among the uses of that forest, this amount of millions of dollars, because that forest provides these services to society, even though you haven't valorized those services yet. Okay, so, or don't build your airport in that mangrove, because then you're going to erode your roads inland, for example, and you're going to have to pay for those roads. You think you're going to get more tourism, more trade through that airport. But if you want to build it somewhere else, not in that mangrove, not in that virgin natural area. That's the thought process. Does it make sense, Rin? That's what we intend.
Yeah, it makes sense. But as you have mentioned, when it comes to other disciplines and working with other people from ecology, for example, they usually have a problem when putting a dollar value to the assets. And this is one of the discussions that I had with one of my colleagues last semester. So thank you so much for sharing your insights.
And you're absolutely right. And we are very cautious on, monetizing, and that's why I use valorizing, not doing a valuation, because it feels to me like it's a trade, but a valorization that is uplifting, highlighting the value of the ecosystem services, right? Highlighting the value for society of the natural assets. It's semantics, and but probably every time we speak about this, we need to highlight this point. We're not trying to trade natural assets. We're trying to understand what is the economic value of the services it provides. By the way, I invite you all, if you're interested in this topic, EBRD will celebrate its annual meeting 2021 virtually. at the beginning of July. We, with other colleagues, are preparing a panel of discussion, very high-level panel discussion, with Jane Goodall, the conservationist, not the UK, the British conservationist that has been doing research on chimpanzees, with Professor Dasgupta, who's an economist that just published the review of the economics of biodiversity, and then a top representative of BNP Paribas, which is probably the leading private sector bank doing investing in nature. I think it will be a fascinating discussion, and the profile of the people there is extremely high, extremely interesting. And the AGM is free, is open, so I welcome you to join the panel. And Lebanon is a country of operations, by the way. We operate in Lebanon, so it couldn't be more suitable.
Thank you. That's actually very amazing. So if you can share additional details like after the session, that would be great.
Absolutely.
Thank you.
Well, good to see you, Reem, and good luck with your PhD program. Okay, so I love the questions. So next we have Sarah Hamad.
Hello, I'm Sarah Hamad. I'm an undergraduate physics student at AUB. So basically, first of all, thank you so much for shedding the light on the topic of nature in policymaking through physics. So basically, my question is about the statement we're saying that we are modeling nature in policymaking, which is basically a brave statement and something so new and interesting. And as physics, I think that's what's special about us. So my question is about the model itself. So basically, I raised my hand and then I lowered it because you talked a little bit about it. So so basically, how did your thought process start about modeling something non-tangible? We want to put value into nature and then give this value to policymaking, like see this has a certain value. You don't see it, but we as physicists do. So how did your thought process on the model start?
Good. Thank you, Sarah. We haven't developed the model quite yet. For example, the Inter-American Development Bank has been working on this for much longer. So if you look at their website, probably you'll find information of specifically what they've done to valorize natural capital. I can share with you the thought process, right? This is something that was in my mind for many years. How can we actually help? And it was a very practical initially. How can we help the countries where we operate monetize their natural assets, right? Make more money out of the natural parks. Make more money out of the small businesses around natural parks or around historical assets. I love traveling. I love history, and I love Lebanon. For example, Baalbek or the Cedars. How can you actually develop an ecosystem of businesses that actually benefit society? So you create drivers in the local communities to preserve those assets, right? So how to maximize the revenues to the local communities thanks to those assets. That's what actually started making me think, are there good examples in the world? That I was thinking about the gorillas in Rwanda, for example. Rwanda gets a very significant influx of money because of the entrances that tourists pay to see the gorillas. It's a very unique situation, and the reason why tourists pay so much is because there is a scarcity of those assets, right? Of the gorillas themselves. So how to think about nature as a way of providing sustainable income to the local community. And then when I started researching, I wasn't discovering anything. A lot of people had thought about this for many decades, right? So we developed the concept. We spoke to our economist. And EBRD is a very relatively small multilateral development bank. We don't have environmental economists per se, but there were people interested in this. So we decided to actually launch an assignment and launch some pilots in some areas of our region of operations where we could test a model, right? Develop a methodology and test it. And we will test it in Kyrgyzstan, which is quite advanced in that sense, right? So that was the thought process. I repeat, the models and the methodologies will not be perfect, of course not, but our expectation is to be able to understand what is the network of associated economic activities to the natural assets, transpose experiences in other countries that have actually enhanced their revenues to those assets, and provide policy measures to our counterparts, not just in the Ministry of Environment. The key is to involve the Treasury and the Ministry of Economy, because very often multilaterals work with the Ministry of Environment, well-intentioned people, but they don't have the decision-making power except for compliance on environmental regulations, right? It is the Ministry of Economy that you need to stimulate and show them that by preserving those assets, by expanding those natural assets, they will increase the welfare, the GDP per capita of the region and the country itself. That's
Great, thank you, Sarah. I think in Lebanon, if you don't talk to the Ministry of Treasury or Finance, you go nowhere, I suppose.
No, that's not true. You have good people. We were talking about Alam Bifani and our counterpart. I had the luck to meet Bifani years ago when I visited Lebanon with our president. I think he's a physicist as well, Ali.
Yes, you told me, and I think I wanted to check that. And if he is indeed, I think we have to invite him.
You have to have him, exactly.
Okay, Carol, we have kept you waiting for too long. We apologize. Carol, over to you. Carol is gone. Oh, here is it. Carol.
Hi, good afternoon. I'm currently a student in high school, so I don't have as much knowledge or experience on this topic, but I am interested in physics and environmental health, both of them. And so I was just curious, you mentioned that you were an engineer before. I was just curious, what made you decide that switch from engineering to physics and then to public policy, and how was that transition difficult for you?
Hi, Carol. Thanks for the question. That's a difficult question. I'll try to respond quickly, and then I can let Katerina intervene, because she's a health physicist, by the way. So her experience is probably more relevant than me. For me, when I was at high school, I didn't know what to study. I wasn't sure. I liked everything, mostly science, but also history. So I liked everything. Engineering seemed to be the most versatile type of studies. Then during the 5 years of engineering, I realized that I liked science. I like knowledge, not just so much the applied topics, but the actual knowledge and the explaining of questions. And CERN was a fantastic place. So I moved to CERN, and then I started my PhD on elimination of nuclear waste, which combined research, physics, but also a purpose, right? Which was to make a source of energy that was a high promise for climate action into a safe source of energy, right? Eliminating the impact of nuclear waste. Of course, as Ali can then refer to, our research didn't go very far. I don't think we have any ADS being built anywhere in the world right now, but we tried, right? And we learned a lot on the way. So ultimately, after finishing my PhD and being quite satisfied with what I had learned, then I realized, okay, I love science, but I also love human interaction and the impact of my work. And seeing the impact of my work, just a bit like doctors have when they cure patients, right? It was to be too late to be a doctor, right? So then I thought international development was hitting all the spots and could benefit from a technical expertise. That's why I chose international development, and I think it was the right choice. I don't think I will move from here anytime soon. So, but Katerina, your experience might be more useful than mine.
Thank you, Adonai. Thank you, Carol. Let me tell you my story, how my transition happened. So, when I finished the university, my specialization was physics of functional materials. Particularly, we've been looking at the medical aspects of this process, and we've been working on physics of radiational medicine, meaning that at that moment, nanotubes and fullerenes have been just discovered, and that was such a major deal, and everyone was so much into it. And we had an idea, so I stayed at the university. I had to work after graduation at the university with an idea to work for PhD. So we had an idea of filling these nanotubes with some special treatments, and we know that graphene is not hazardous for the human's body. So the idea was, the general principle was to fill it with some treatment and then to deliver it straight to the cancer cells without bringing any damage to the healthy cells. So it could be really an advanced technology and something which may help to cure this problem forever. And since there were no special samples available in Ukraine, I had a long negotiation with Frankfurt University, and they agreed to deliver samples for free for Kyiv National Taras Shevchenko University. And we've been working together because it is a process to produce these nanotubes as well. And finally, I was so happy because my samples were sent to Ukraine. And you know what happened? Ukrainian customs required some kind of explanation. What is that? What is that hazardous type of something dark you have in your push? And you need to prove that this is not dangerous for the environment, that this is something which may be really broad, that this is cause no damage. And I really needed support from my university to fight this. I've been trying to negotiate this with the customs for almost 2 months. At some point, I realized that there's not much support from university because they can't kind of justify something which is not produced by the university. At the same time, customs were so strict, and that was the moment. So finally, just to tell the story short, finally I couldn't make it to get my samples to continue my work on PhD. And that was the moment I realized something is going wrong with these policies in this country, and something that really needs improvement. And you have to have some flexible mechanisms on the level of policy making, because it's not black or white. You may need some grayish area in between, some explanations, some options how to justify this and that. And that was my non-return point of physics, because I lost motivation and I started looking around. So then, to tell you, I've been working in oil and gas companies, in electricity companies, implementing projects for EBRD, from the side of real contractors. And then I've been working in big EU-funded technical program called Innegate Technical Secretariat. You may Google, it's still on the web. This program was covering 6 different areas: energy statistics, renewable energy, conventional energy, and all the awareness-raising events and conferences. And we've been even organizing ministerial conferences. And that was the moment when I slightly touched policy aspects, because I was a monitoring expert, monitoring consultant, because of course you can process different data and present them on a good visual shapes when you get them. And then I really lacked the knowledge on project management, so I started looking at project management programs. But when I got my project management degree, I came back to the policy because in 2016, Prime Minister Groisman, at that point of time, has launched together with EBRD a huge program which is called Ukraine Reform Support Architecture. It's still going on. Original idea was to have this program for 3 years. And the idea was to embed people from business, people with different backgrounds into the various ministries to help civil servants, conservative civil servants who are used to do their work just this way and no deviations, to look broader, to have some support and help them shape new policies and help them shape regulations. And I'm happy to say that I started this program and it's still ongoing. It just was my time to migrate and to start working with Adonai. So it's a long process, and sometimes it's a painful process, but sometimes it's a very nice changes to your life. And you shouldn't be afraid if something goes wrong. maybe it will bring you to something even better.
Katrina, Adonai, do you mind if we go maybe 5 to 10 minutes over time? Is that okay with you? Okay, I know it's like a long week, but
yeah, I know that's I'm fine. I was just now checking my calendar. Yeah, that's fine.
Good, thank you. Next, I have Andre.
Thank you very much. Hello, I hope you can hear me. Thank you very much for this conversation. My name is Andrei Covatario. I'm a nuclear engineer, but I'm now pursuing a master in public policy in Oxford. Although I already have experience in the public policy sector, I can clearly relate to the discussion about the transition from one career to the other, from one sector to the other. Additionally, I'm working now under the supervision of Ali on some subjects, and I thank him for that. I wanted to build a bit on Reem's question earlier on the natural capital and the idea of trying to assess a value to the utility provided by the resources. In fact, the use of these natural resources have only two outputs at the end of the day: utility and waste, right? And there is this school of thought, some call it entropic economics, which was developed by Georgescu Rogan and other scholars, which basically states that since the natural resources are, at the end of the day, finite, limited, putting them in economic processes will lead us on the long run to waste that cannot be basically reused. In other words, the resources available and their utilization is limited in time and or volume, basically. I was wondering, what do you think about this basically pessimistic view on natural capital, and how do we actually model this somehow? Thank you.
That's a very technical question. I think it's a pessimistic point of view, that's for sure. And I think I personally think that might be flawed in the hypothesis is based in itself. In natural resources are finite but can be utilized in a sustainable manner. There is the so-called regenerative rate of natural resources, whereby if we utilize resources below, like at a slower rate than the regeneration of nature, we can sustain those renewable resources forever. So we can actually manage our natural capital in a sustainable manner. So but second point on the utility and waste, it was surely utility, and that's the concept of ecosystem services. Waste, well, I would say that the concept of circular economy is actually a refutal of that point, right? The fact that we can actually design and utilize our resources to almost permanently reuse those resources, right? So I don't. That's all I would say. That I wouldn't agree with any of the two hypotheses of that point of view, Andre. But I would be glad to debate on this bilaterally, because we're not going to keep 60 people talking about this. But it's an interesting topic. But I think it's excessively pessimistic and actually not very reflective of reality. Read the Dasgupta review if you haven't read it, because it's a very, very comprehensive, well-written, and incredibly compelling a write-up that touches on economics, on finance, and on conservationism, and it addresses some of those issues, I think.
Interesting. I found this topic fascinating myself, and I think I need to educate myself on it. So I look forward to reading that reference that you mentioned, Adonai, myself. Professor Malik Tabbal, so sorry for keeping you waiting, but you've been so generous with us. Malik, over to you.
Oh, okay, thank you, Ali. Thank you, Adonai and Katrina. A really fascinating discussion. This is the second time, so this is our second seminar, and I keep telling myself that I wish I had been a student, or such seminars were offered to us when we were students back in the, I shouldn't say it, but I will, in the mid-'80s. Anyway, I had a couple of questions that tackle practical aspects. One of them was already mentioned by Ali Badruddin and Carol Hashim about your, both of you, your personal experiences in this transition. I myself had a mini transition going from physics to applied and engineering physics, and it was daunting at one stage, but I survived it. I think you've addressed it already, but just a small, very specific question. How useful, and that's also for the benefit of, mostly for the benefits of the student in the, among the participants, how useful it was for you, Adonai, to do an MBA. You mentioned that you did an MBA at one stage. Okay.
I think it was very useful because MBAs were are used for technical people, especially for engineers, to do a career change, to explore what business has to offer. In fact, I think MBAs were originally designed for engineers to move into business. So for me, in my case, it was useful to open the doors of a whole set of potential employment opportunities, right? And it actually gave my profile more credibility to step into finance, because my goal was to work on finance, not just on any kind of development work, but on finance. So it helped me a lot. I'm very grateful. If you think about an MBA, though, think about top schools, because those are the ones that, I mean, you know, the knowledge is universal. So, but the name you associate your CV with is key, right? So,
but probably you need to steal a bank in order to afford the
sorry, say again.
Probably you need to steal a bank in order to.
Expensive. They are expensive. Unfortunately, they are expensive courses. That's the downside. You're right. Right. It's not the only solution. It doesn't mean that you need to. You only should do an MBA if you really know what you want to get out of it, right? Because it's a big investment.
Some programs offer scholarships, so people should also try their chance.
And there's not many physicists that apply. So, you know, and you bring such an interesting profile that business schools, top business schools, would be very glad to bring physicists.
That's an amazing advice. And thank you for bringing that up, because I have many friends who did and are doing MBAs in top schools, and they mentioned the value of diversity. And they mentioned that these top schools, when they decide with whom to accept, they actually value diversity. And if you are somewhere in the minority in whatever category, then maybe you have a better chance. Malik, I think you have a second question.
Yes, actually, this comment by Adonai leads me to the second question, which is one of the important aspects of this whole initiative is, on the long run, to be able to integrate policy thinking into the teaching of our department, the teaching and research. Okay, so obviously, perhaps the easiest way and fastest way to do it is to ask our physics major, and this actually also applies to other science majors like the chemistry majors and so on, to take a course in policy. Okay, that's the easiest way of doing it, and we tell them, okay, why don't you take this elective in policy and in social science? How do you see a more structured way of integrating policy thinking into a physics curriculum? This may take a long time, so this is something perhaps that we should discuss among ourselves separately, and that's I think that's an important aspect or vision we need to have. But perhaps you and Katrina, just a couple of sentences about ways of integrating, practically speaking, policy thinking into a physics curriculum.
Katrina, maybe you start.
I may probably reply not from the point of view how to integrate into the physics, but how to integrate policy thinking into the thinking of those who never applied it first. Because like within Ukraine Reform Support Architecture program, there was such an initiative when we've been taking civil servants of older formation who are used to work by certain principles, but without broad thinking, without flexible approaches, without will. They were mostly willing just to do their job, what is prescribed by their job description, but not to think broader. And we've been taking them out, and not only for the training, but for 2 days event, taking them out of the city, bringing to some nice area in the forest, literally locking them for a few days, and mixing lectures on public policy, educating them and making them interact, to develop empathy, to develop more communication skills. And, you know, first, nobody wanted to go. It was so hard to mobilize people willing to go for such exercise during their own spare time on weekends, like starting from Friday evening and coming back Sunday evening home. But then when the program showed that this unites people who are going through this program, that they are getting extra knowledge, that they can start seeing broader opportunities, how to ease their own job, how to interact with colleagues, how to share, how to prepare policies in a more structured way. This started to work for us, and we had a competition for those who applied for this type of training. So maybe this is something like extra, which is not supposed to be added into the curricula, but something extra which you may consider like even out of study hours, but something which may be joining engagement, communication, and training. That's maybe something I could propose.
I think those are really valuable points. Thank you, Katrina. Adonai?
Yes, all these questions are quite good. I had never thought about how to integrate physics into policy making into physics, but I guess just off the top of my head, a reasonable set of modules would be to segment a policy class based on the areas where physics and policy interact the most. And I was thinking about 2 key areas, but there will be many more. Well, 3 key areas, right? One key area would be policy of research, right? How does public policy affect research and affect research in physics in terms of budget, in terms of what are the different models, what are the societal and economic value that a higher budget or for physics and for research in general brings to society. So actually physicists understand why the work in physics is important for our environment, not just pure knowledge, but because it actually brings value to society. The other is that, you know, physics has a key role, as you know better than me, on understanding climate change, right? So the interaction, the overlap between physics, climate, and environmental sustainability is key. Modeling ecosystems, that could be another module, like another 1 or 2 lessons, right? So how physics modeling helps model climate change, helps the adaptation and the resilience of economies to climate change, and also overall how to model ecosystems, right? And how different physical outcomes and physical outputs can help improve models and you know and develop policy measures to maintain our natural capital. That would be another one. And of course, energy policy is key as well. So those are 3 areas that where you could start building your program. And I'm sure there will be many other areas to segment, but yes, it makes a lot of sense. Maybe it's an elective, but definitely something that would give physicists a step towards, you know, how their studies touch the common policy. An unrelated comment to the MBA that came to my mind. Sorry to digress now, to take it back. Another good source of experience, of very useful business experience, if you ever want to move to transition, is working for strategic consultancies, for McKinsey, for BCG, for Bain. Those employers are, I mean, I never worked for them, but I have many friends because I studied with many people that work. They really value diversity. They value numerical skills, by the way, ability to calculate quickly, to understand what are the key drivers of a business decision. So analytical skills, numerical skills, and they value, as I said, diversity. And most of them, they mostly hire people from finance, but because they don't get so much access to physicists. So instead of an MBA, that would be a great way of training yourself to a broad range of sectors of economic activities and being paid at the same time. It's very exclusive. It's very hard to get to those entities, but I think it's an ideal way of, you know, training yourself while on a job. work a lot of hours, but you know, that's the price to pay.
A more skeptical view of debate that goes beyond to have a conversation when we meet in person, Adonai, about this. That we are over time, so I will not ask my questions. I had so many questions. I had questions on the balance between mitigation and adaptation. I have questions on nuclear energy. I had questions on the EU Green Deal. But I realized that there is no time for this, okay? But I'm also hopeful that your generosity is extended and you give us more of your time in the future, hopefully in person, right? But I know very well, Katrina and Adonai, that you had a very long week. So on behalf of the physics department in EUB, on behalf of our partners and collaborators, our students and guests, we cannot thank you enough for giving us this week. It has been fascinating. Frankly, I was a bit scared about having this mix between the personal and career and between climate change and policy, but I think it went really well. So over to you if you'd like to say any final words. Are immensely grateful for you.
I would just say that I'm the one who's grateful for the invitation, for the opportunity to speak, to share my experience and and especially, Ali, look back at the work I did 20 years ago, which is a bit scary when I think about it, but it was very, very rewarding to go back, dig out the photos, dig out the graphs, trying to remember what I was doing then. So it was a real pleasure, and it's always, I come from a family of teachers, so it's a real pleasure to share experience, knowledge with interested parties and with students especially. So thank you for the invitation. Anytime, whenever we can travel after COVID, I'll be delighted to visit Lebanon, a country I love. And again, the pleasure was ours.
Thank you, Adonai. All right, so thanks again, everyone. We see you hopefully in the next session. Next session, we will host Dr. Laura Grego, who will tell us about her exciting research on the intersection between space and public policy, something that is very exciting, and we look forward to her discussion. Take care, everyone, and see you soon. Bye-bye.
Bye-bye. Thank you very much.
Thank you.
Thank you. Bye.